In 1937, Alan Turing published On Computable Numbers, which established the field of computer science. Turing considered the problem of describing computation mathematically. To do so, he imagined a machine that read a tape, possibly infinite in length. Each square of the tape was either blank or contained a symbol. The machine could be in any of a finite number of states. Now the tape head would be at some location on the tape and read the symbol at that location. And based on that symbol, it could do any combination of move left, right, or stay in place. It could replace the current symbol with another, which we'll write this way, where X is our new symbol, or erase the current symbol, where delta is the blank symbol. You could think of this as print X or print blank. Or it could change its internal state. And these could be done in any specified order. For example, let's consider a Turing machine with the following transition rules. If the machine starts in state Q0 on a blank tape, what will this machine do? Since the tape is blank, it reads the symbol empty, delta, while it's in state Q0. So the instructions say R P1 Q0. We could read this as move right, print 1 in the current space, and then change to state Q1. Now the machine is in state Q1. It reads the symbol at the tape head, which turns out to be a 1. And so the instructions say erase the symbol, P delta, move left, and return to state Q0. So now the machine is in state Q0, and it reads blank. So it moves right, prints 1 in the current space, and changes to state Q1. Now the machine is in state Q1. It reads the symbol at the tape head, which turns out to be a 1. And so the instructions say erase the symbol, P delta, move left, and return to state Q0. Now it's in Q0 and reads the empty string. So it moves right, prints 1, changes state to Q1, and it's going to keep cycling back and forth, printing 1 and then erasing 1. In other words, it enters an infinite loop, and we'll talk about this a little bit later on. But let's consider changing this slightly to a new machine. And notice the only difference is that instead of moving right, then printing, and then changing state, we're going to print, then move right, then change state. So since the symbol red is empty, we'll put a 1 in the current space, and then move right, and then change to state Q1. Now we're in state Q1, but the symbol red is empty, so I'll put a 1 in the current space, and then move right. And again, the current space is empty, so we'll put a 1 in the current space, and move right. And this time, we go into this endless repetition of printing 1 and then moving right. And if our tape is assumed infinite, we'll continue on forever. And again, we'd like to avoid that, but let's not worry about that quite yet. So let's consider a Turing machine that has a little bit more complexity in its behavior. So if the machine starts in state Q0 on the tape shown, what will the machine do? So note that the machine is in state Q0 and the current space is blank, so the machine moves 1 place to the right. Now the current symbol is a 1, so it moves 1 place to the right and changes to state Q1. The current symbol is now 1. The machine is in state Q1, so it moves right, but stays in its current state, still Q1. Now the current symbol is blank. Since the machine is in state Q1, it will move right and then change to state Q2. Again, we read a blank. We're in state Q2, so we move right and stay in state Q2. In the next place is a 1, so the machine will print a blank, erasing the symbol, and change state to Q3. Since it hasn't moved, the current symbol is blank, so the machine moves left. The state is still Q3 and the symbol is blank, so it moves left again. The state is still Q3 and the symbol is blank, so it moves left again. The state is Q3, but now the symbol is 1, so the machine moves right and shifts to state Q4. The current symbol is blank, so the machine prints 1. The current symbol is 1, so the machine moves right and changes to state Q1. Now, notice that we're in state Q1 and a current symbol is blank. This is the same configuration we had earlier, but notice that the moves afterward move to the first one after the blanks, erased it, moved back to the first blank space, and wrote a 1 in it. So the overall effect is to move the 1. Consequently, if this machine keeps running, all of the 1s on the entire tape will become juxtaposed.